Assalamualaikum warahmatullahi wabarakatuh and good morning to you guys. Okay, maybe afternoon, maybe evening, right? Good afternoon, good evening to you guys. Okay, how are you? I hope all of you are fine. Okay, so today our topic we will learn about energy changes in reaction. Okay, you have learned this in year 8, if I'm not mistaken. Yes, year 8. Okay, the red color textbook. Okay. But yes, you will learn again in your year 9, but very detailed, in a detailed way. Alright, so energy changes in reactions. Our work today is energy changes in reactions. So we will learn about exothermic and endothermic reactions. So who knows about what is exothermic and what is endothermic? Alright. So you can see from this picture, exothermic versus endothermic. So exothermic, you can see the heat is given out. See? The arrow, the heat is given out. How about endothermic? See the arrow, the heat is absorbed. Alright, it absorbs the heat from the surrounding. This one, exothermic, gives heat to the surrounding. Okay, understand? So in this topic, for this subtopic, we will learn about the reaction of exothermic and endothermic. Okay, and the important thing, the most important thing for this exothermic and endothermic reaction is the diagram of exothermic and endothermic reaction. Okay, let's see. So there are several key points or key terms that you need to understand. First, okay, in IGCSE, it will always ask you this question, the term, the definition. So what is the exothermic reaction? What is the definition of exothermic reaction? A reaction in which there is an overall transfer of energy to the surroundings. Okay, you transfer the energy to the surrounding, or you release the energy to the surrounding, or you release heat to the surroundings. Okay, endothermic reaction, a reaction in which there is an overall gain of energy from the surrounding. So you absorb the heat from the surrounding. You absorb the energy from the surrounding. And the last one, the key terms or definition that you need to know, bond energy. What means by bond energy? The amount of energy required to break 1 mole of covalent bonds in gaseous molecules. Okay, this is quite complicated, but it's okay. We will learn about this bond energy later on. So the summary for this, the big picture, the summary of these energy changes, there is always an overall energy change during a reaction. When exothermic happen, there is changes, energy changes. When endothermic happen, there will be energy change. So some reaction give out energy overall, some taking in, right? Some give out energy, exothermic, some take in, endothermic. So when we use fuels, energy is given out overall mainly in the form of heat. That's why we use them. We use some reactions to give energy in the form of electricity. Okay, let's exothermic and endothermic reactions. During all chemical reaction, energy is given out or taken in overall. Some chemical reactions are exothermic, means that they give out energy. Exit, out, out. The others are endothermic, they take in energy. So remember, see here, exo is not a band group, okay? It's not a Korean band group, alright? I know you know, okay? For example, Azara, you might thinking this exo is a Korean band group, right? No, exo is exothermic, means it is exit. So exothermic means energy is given out. Okay, so I highlight here. Exo means energy is given out. I will ask you later on what means by exothermic reaction. You need to know. So this is the comparison of exothermic reaction and endothermic reaction. Where is my laser pointer? Right here. So exothermic reaction, energy is given out. For example, they give you the reaction between hydrochloric acid and magnesium. Usually, okay, usually, I don't say all, okay, usually. The exothermic reaction, when you touch it, it will feel hot. Okay, because it gives out energy, so it will feel hot. For example, in this beaker, you touch this beaker, you feel hot. Okay, usually not It doesn't mean it needs to be hot, but usually for exothermic reaction, it will be hot. Alright, so it is hydrochloric and magnesium ribbon, so it gives out heat energy. So it has thermometer here, so you just measure the thermometer before reaction and after reaction. So if there is increment of temperature, it will be exothermic reaction. So there is a rise in temperature. So this is important. This is important, guys. So the energy level of diagram. Okay, you can see this energy level of diagram. So this energy, okay, and this, what happened here? So reactant over here, product over here. Okay, and you need to draw this arrow too. Reactants, product, energy is given out. Reactant is there at the above, products below the reactant. Okay, so the product have lower energy. Okay, product have lower energy than reactants. Okay, so more example of this type of reaction. Where is my laser point? Okay, over here. So more examples of this type of reaction: the neutralization of an acid by an alkali, the combustion of fuels, the reaction between iron and sulfur. So for about endothermic reaction, energy is taken in the reaction between sodium hydrogen carbonate, baking soda, and citric acid. Okay, you can see there is fall in temperature. Like I said just now, usually endothermic process, when you touch it, it will feel cold. Why? Because it cold and then it need to absorb the heat from the surrounding to make it warm. Okay, so it is cold reaction. Alright, so when you touch it, it feels cold. Usually it's endothermic reaction. Okay, so there is a fall in temperature, and yes, you need to memorize this energy level diagram. I'm sorry, I need to highlight it well, right? So I just color this. Can you see? Yeah, you can see. Of course you can see. Don't say you cannot see. Of course you can see. It's not hard to see, right? It's the red color. It should be nice. Okay, yeah. So energy over here, you need to label the axis. Okay, energy, and then you can see the reactant and the product. Okay, so the reactant is lower than product. So the product have higher energy than the reactant. Okay, the reactant is low, the product is high. Okay, so more example of this type of reaction: the thermal decomposition of calcium carbonate, photosynthesis, and reactions that take place during cooking. Okay, usually guys, for example, you need to memorize at least 2 examples. Okay, what is the example for exothermic? What is the example of endothermic? But the important thing is you need to memorize these diagram, both of the diagram, where you should put product, where should you put reactant, and don't forget to draw this energy is given out or energy is taken in. Okay, the what they call this thing, the arrow. Okay, for exothermic arrow, it point downwards. Okay, for endothermic, it point upwards. Okay, so please remember this thing: where should you put reactant, where should you put product, which one has a higher energy, which one has a lower energy. This is very important in this topic. Okay, the diagram. Okay, here they also show sometimes. Okay, sometimes the question also asks the activation energy. What is EA, teacher? What is EA? This is what we call activation energy. You will learn this. You will see most of this diagram in the rate of reaction topic. Okay, so this is what we call activation energy. Not this one, not this energy release. Usually this one. Okay, the bumpy one. Okay, right. So you can see this is what we call EA, or activation energy, or actually E stands for energy, A stands for activation. So energy activation, or yeah, activation energy. So what is activation energy? In chemistry, the minimum amount of energy that is required to activate atoms or molecules to a condition in which they can undergo chemical transportation or transformation. I'm sorry, not transportation. Transformation or physical transport. In other way, this one is simpler one. In other way, the energy required to end the chemical reaction, the energy required to bind a substrate to an active site, the energy required to break the bonds of reactant molecules, the energy required to reform bonds in product molecules. Okay, so in exothermic, you can see reactants still higher than products, okay, but and the activation energy is over here. So for endothermic reaction, reactant is lower energy than the products. Okay, so energy is absorbed. Okay, so you need to know where is energy released, where is energy absorbed, and you need to know activation energy. Usually activation energy is from reactant, from the bump here until the reactant. Where is the reactant? Okay, the reactant is here, the bump is here, so the activation energy will be here. So where is the bump? Okay, the bump here, and then the reactants here, so this will be your activation energy. How about energy release? Is between product and reactant. So this is reactant, this is product, this is energy release. This is product, this is reactant, this is energy release. Understand? Okay. So this is a comparison of endothermic and exothermic reaction. Okay. How exothermic release heat, endothermic absorb heat. Okay, so energy content of reactant is higher. This one you already know, I already explained. So heat of reaction, this is delta H. Okay, heat of reaction, delta H has negative value. So what means by negative value? Negative value, for example, negative 139 kilojoule. Gitu. Alright, so this is positive value. 139, for example. Okay, so this in this exothermic and endothermic reaction, yes, you need to label the value, negative or positive. You cannot simply say, alright, 139 kilojoule. Is it so if you say it like that, we don't know whether it is exothermic or endothermic reaction. Alright, so this is the example: neutralization, acid combustion of fuel, hydrated salt, heat decomposition. You need to some of the examples of exothermic and endothermic reaction. So you need to read. Understand?